Hello friends, welcome to our channel. Let's have a look at a newly appeared problem, problem 3460, longest common prefix after at most one removal. In this video, we're going to explain a solution based on two-pointer method. But here, in order to incorporate the requirements, in other words, at most one character from this string s, so we need to introduce a flag variable in order to carry out the program or the whole solution. So here we are given two strings s and t. So we want to return the length of the longest common prefix between s and t after removing at most one character from s, right? So here s can be left without any removal, right? So this note can be like something like this. For example, this kind of problem, you have two strings, like say ABC, and then another one also ABC or ABCD, right? Let's call this this one S, the others are T. So in this scenarios, you don't need to use the delete operation. But if you look at example 1, so in order to get this 4, you need to delete the x in the first string s, right? So that's the problem requirement. So in example 1, you need to delete the L, then you get the remaining 7 characters. So the length is 7. So example 3 is identical as here, ABC or ABC, right? So example 4 is a special case because the 2 does not match, so you need to return 0. So here the s and the t can have length up to 10 to the power 5. In other words, we need to think of term complexity. Due to the two-pointer strategy, actually we can do the problem in O of n space or O of m plus 1 at most. This s and n is the larger of s and the length of s and t. So with that said, let me first look at the register coding, and in between we can explain some details. So first I'm going to get the length of the two strings, right? And then we are going to set the two pointers at the very beginning, right? Also, we can introduce a result variable. Thus, we match a pair of characters, so we are going to increment the result by 1, and finally we just return this result variable. So, and then we need to also use a flag called used. If you already did a deletion, you cannot do a second time, right? That's the purpose of this flag variable. So now let me use this two pointer with a flag. So while I is less than m, so here the logical word should be add, right? Well, j is less than n. So first, if si and tj are the same, then meaning that we are matching in one pair of characters. So we are going to first increment the result by 1, right? And then we are going to shift I and j to the right by 1 unit. This part. Otherwise, so we can think of deleting the current character at I. So, but this is if we have already used the remove operation, we cannot use anymore. So we need to break here. Otherwise, if we haven't used yet, then how could we check we need to delete this character? That's the thing here. First, because we want to consider the I plus 1 index, so we need to ensure I is less than m plus 1, minus 1, so that we can consider I plus 1. And the second is that if si plus 1 equals tj, the current index. So if this were the case, actually we should increment I by 1, and also increment by I by 1, meaning deleting si, right? So in this case, we need to reset the used variable to be true, right? So otherwise, so if I is already at the end, or this 2 does not equal, right? So we don't need to delete that. So we also need to do break. So finally, we just need to return the result variable. So that's the full coding for this problem. Let me first run it. So not right. So let me see where's the problem. So have m and n, ij equals 0, result equals 0. Use is for so here used is false, right? So now let's run it. Yeah, it passes the 4 test cases. Now let's look at the generic case. Yeah, it passes all the cases. And here, actually, this problem is very special because we don't do deletions from T. In other words, I and J are not symmetric. In this way, actually, this observation can help us to delete without, we can solve the problem without introducing this result variable. Let me copy this solution. And what I want to do is we regard this one as version v1. And then what we do is we delete this one. And we don't need to increment this result. And but here, what we want to return is the G, right? Because if G is originally meaning the index, but if you break this while loop, actually what we get, for example, if the length is n, so this might be stopped at n, right? The length is 1 larger than the index, so J is exactly the same as the result variable in the first solution. So we can test that. Yeah, it passes the 4 test cases, not the generic case. Yeah, it passes all the cases. So that will be the second version of solutions. In other words, we don't need to introduce an extra result variable for this problem. So, well, for the term complexity analysis, so here actually you do this while loop. So at most you do, so because the prefix is at most length n, right? So overall what you do actually, the term complexity will be O of I guess O of n, right? So for sure you can, if you don't want to be very accurate, so it will be O(n plus m). This is for sure an upper bound. Well, for space complexity, so it's O of 1 because we just use this ij and the result. Well, in the second one we just use this ij. Also, I forgot to mention we introduce a Boolean variable. So with that said, I guess that's it for the current problem and the current video. So you're welcome to dive deep in our channel and look at different playlists. Hopefully it will be of use for you.